Number 5, find dy dx for y equals 7 arc cosecant of 4x. Or wait, we know the derivative of arc cosecant is going to be negative u prime, or negative du, however you want to say that, over the absolute value of u times the square root of u squared minus 1. So that's the formula that I'm going to be using. U is 4x, 7 is a constant, so it's just going to tag along for the right. So we're going to put 7 times, using this derivative, negative u prime. Negative, the derivative of 4x is 4, over the absolute value of u, which is 4x, times the square root of 4x squared minus 1. Okay, a few things that I'm going to do to try to clean this up a little bit here. First of all, let's just keep 7 times negative 4 over the absolute value of 4x. Since the absolute value of 4 is just 4, I'm going to pull the 4 out of the absolute value signs. The x I can't because I don't know what x is. And then also in here, 4x squared, we're going to square both parts, so 4 squared is 16, and x squared is x squared. Okay, and then from here, the 4's can cancel. And I'm going to turn that into negative 1, and then I'm going to put a 1 underneath the 7 and multiply across. So my final answer, this is y prime for each of these, y prime will equal negative 7 over the absolute value of x times the square root of 16x squared minus 1. And that would be my derivative. Okay, number 6, find the derivative. F of x equals arc cotangent of e to the x over 2. Okay, so when we're finding arc cotangent, we know that our derivative is going to be negative u prime over 1 plus u squared. Okay, in this case, we know our u is e to the x over 2. So here we go. The derivative is going to be negative u prime. Well, to get u prime, e to the x over 2, we're actually going to have to do another little thing. I'm going to rewrite this as e to the 1/2 x. It means the same thing. And then we know the derivative of e to the u is e to the u times du. So we've got another little u going on in our problem. So the derivative of e to the u is e to the u, so e to the x over 2, times du. The derivative of 1/2 x would be 1/2. And then all over 1 plus e to the x over 2 squared. Okay, then from here I'm just going to clean it up a little bit. If I put a 1 underneath that 1 and multiply across up top, I'm going to get negative e to the x over 2 over 2 over 1 plus e to the x over 2 squared. We are going to multiply the exponents when it's a power to a power, so x over 2 times 2 is just x. All right, now I have a complex fraction, so I'm going to make the denominator a fraction, and now I can multiply by the reciprocal, so I'm going to have negative e to the x over 2 times 1 over 1 plus e to the x. And then multiplying across, I'll get negative e to the x over 2, and on the bottom, I'll just get 2 times the quantity, 1 plus e to the x, and that will be my derivative. Okay, number 7, what is d dx of the inverse cosine of x over 7? Again, d dx is just the derivative. This is inverse cosine this time. We know the derivative of inverse cosine. All of these have been c's, so they're all negative. Negative u prime over the square root of 1 minus u squared. All right, so this is our u. I am going to rewrite that as 1/7 x, because that just makes more sense to me. Okay, so the derivative is going to be d dx is equal to negative u prime, the derivative of 1/7 x is going to be 1/7 over the square root of 1 minus x over 7 squared. All right, now it's just a matter of getting it cleaned up. So negative 1/7 over the square root of 1 minus, we'll square both the numerator and the denominator. I'll get x squared over 49. Okay, the next thing that I'm going to do is get a common denominator, so I'll have negative 1 over 7. I'm going to multiply the top and the bottom by 49. So I'll end up getting 49 minus x squared all over 49. And now since I know that the square root of 49 down here is just 7, I can rewrite that. So I'm going to have negative 1/7 over the square root of 49 minus x squared. This will now be over 7. It's no longer in the square root. And now since I have a fraction divided by a fraction, I can multiply by the reciprocal. So negative 1 over 7 times 7 over the square root of 49 minus x squared. 7's will cancel. I'll get negative 1 over the square root of 49 minus x squared, and that will be my derivative. Okay, number 8, evaluate arc secant of -2 and arc tangent of 1. So we're looking for what angle would produce that answer. The first thing, if we have secant, I know that it's equivalent to cosine, but it's going to be the reciprocal of the cosine. So instead of -2, I'll be looking for -1/2. So what I'm looking for here is the cosine of what angle will give me an answer of -1/2. So if I'm thinking of my unit circle, the two places where the cosine would equal -1/2 would be 2/3 pi and 4/3 pi. But if you think of the range of arc cosine is defined from 0 to pi, so we're only going to accept the answer that's between 0 and pi, which would be 2/3 pi, which is going to be right here. 4/3 pi would be down here. Okay, arctangent, we're going to change it into sines and cosines. So this is really saying the sine of what angle divided by the cosine of that angle is equal to 1. And I know, so we're looking for the values would have to be the same so that when I divide them that they get 1. I know the two places that happens is at pi over 4 and at 5/4 pi. And if I'm looking at my unit circle, I know that arctangent is defined from -pi over 2 to pi over 2, so we're just in this area. Pi over 4 is within that range. 5 pi over 4 is over here, and that is not in the range. So pi over 4 would be my answer for that one.